Okay, for this Lagrange multiplier question, we're asked to find the maximum, and minimum values for this function f of x, y, subject to these constraints. So what we need to know is that we've got the objective function, we've got the constraint function, this g of x. So what we end up with is that the gradient, why did it change colors on me like that? The gradient of f will be equal to some multiplier times the gradient of the g function. So we'll call this g of xy. Okay. And so what is the gradient of f? Well, the gradient of f is the vector when we take the partial derivatives. So derivative with respect to x is going to be 2x, and that's going to give us in the x direction, or the I direction, right? The derivative of y is going to be 2y, and that's in the j direction. So here's our gradient of f. Our gradient of g is going to be similar, 4x to the third I plus 4y to the third j. Okay, so it comes from the derivatives here. So those are our two, so we can set them equal to each other with the Lagrange multiplier. So we get 2x I plus 2y I equals some multiplier times 4x to the third I plus 4y to the third j. And so since these vectors are equal to each other with some multiplier through it, we could distribute the multiplier through, right? Which we could do. So the components have to be equal, so that tells us that 2x needs to be equal to 4x to the third lambda, and 2y, this part has to be equal to this part, which is 4y to the third lambda. I have a hard time drawing lambdas. Okay, so we start from there. So we now just need to solve this system of equations. Let me see if I can do a little bit better job on my lambdas. Let's see. I'll just do it carefully. There we go. There's, I guess, a little better. So first of all, we know the only way that 2x could be equal to 4x to the third without lambda is, well, certainly if x is 0, 0 equals 0. So x equals 0 is a solution, and for the same reason y equals 0 is a solution here. So when x and y are 0, that's a solution. That's a solution to this system, and that would give us x plus y, x squared plus y squared, so 0 plus, it will give us a value of 0. Okay, so that's one option. That we can check. That's a potential solution. Well, certainly this one when x is 0, this one when y is 0. So let's make the assumption. Where do we want to go first? Okay, let's go ahead. Let's have if x is 0, this is a solution, and so what that allows us to do is let's see what happens when x is 0. So let's go with this function with x being 0, what would y be? So if x is 0, we get 0 to the 4th plus y to the 4th equals 28 from up here. So that's just y to the 4th equals 28. We have to take the 4th root of both sides. That gives us y equals the 4th root of 28. It's even, so it gives us a plus or minus. Similarly, if y is 0, what would x be? So we'll just shorten it up. That's x to the 4th equals 28. So x could be, again, plus or minus the 4th root of 28. So that's a potential solution there. And one more thing. Let's see. What if x and y are not 0? Could we get the relationship that they would need to have? Well, these would have to be true. So what we can do to try to see what the relationship between x and y are is we could, since this is an equation, we could divide each equation by the other. So we take 2x, 4x to the 3rd lambda, and we divide both sides by the same thing. Okay, so 2y is the same thing as 4y to the 3rd lambda. These are equal. So we do that. And then when we do that, we see we get lambda divided by lambda is 1, 4 divided by 4 is 1, 2 divided by 2 is 1. And we could cross multiply. That gives us xy to the 3rd equals x to the 3rd y. Divide this side by x, actually both sides, and we get that y to the 3rd equals x squared y, then divide by y, and you'll see that you get y squared equals x squared. Take the square root of both sides, so y is equal to, you have plus or minus here somewhere, not square root of x, just x. Okay, so that's an option. So then what we've got to look at is g, and then y is equal to plus or minus x. So what happens when we plug that one into the constraint? So that's the only other one, and basically lambda, we don't have to solve for lambda, we just know there is some lambda that makes this happen. And again, it canceled out, but these are all the potential solutions, and what we're going to have to do is plug them all in, see which one gives us a maximum value, which one gives us a minimum value. So these are all satisfying the constraints, because we have to. You can't be outside of this area. And then what we do is then we're going to test it in the f of xy function. Okay, so if we plug in x plus, so what does that give us? Well, that gives us, and again we're using this function up here, so we get x to the 4th plus or minus x to the 4th equals 28. So plus or minus x, when you take it to the 4th, it will always become, whether it's positive or negative, it'll always become positive because of even power. So this is really x to the 4th plus x to the 4th, which is 2. X to the 4th equals 28. Divide both sides by 2. Gives us x to the 4th equals 14. Take the 4th root, so we get that x equals plus or minus the 4th root of 14. Similarly, we would change I think that's the same thing. So anyway, that gives us that the solution so far. When x is 0, y can be plus or minus the fourth root of 28. We get that x is plus or minus the fourth root of 28. With y being 0, that's impossible. Then we get, I guess we checked this one here. So x can be plus or minus 14 when y equals x. So when it's, I guess, yeah, from this one we get two answers. So we get x is positive fourth root of 14, and when that happens, we plug in positive fourth root of 14. We get that y would be plus or minus, right? So let's see, how am I doing this? So then y is plus or minus that. This part here, and when x is negative 14, negative fourth root of 14, y is still plus or minus. It's actually the reverses, but we get two answers there. Okay. I don't know. I would potentially list this as just plus or minus, just as one set. But there's actually, again, you can see there's 2 points here, 2 points here. So there's a total of 4. There's 2 points here. There's 2 points here. So that's 2, 4, 6, 8. I guess 8 points for us to check. However, what are we checking it in? We are now going to see which one gives us the maximum value of this function, which was just x squared plus y squared. Right up here. We want to see which one gives us the maximum value, which one gives us the minimum value. So we just start plugging things in, and notice since they're going to be squared, the plus and minuses really don't matter so much because they're going to get squared. And since it's a balanced function, these two should give us the same values. So it looks like we could examine these ones. These are going to have the same value, and these will have a same value. And so let's look at this one first. So f of 0 plus or minus fourth root of 28. So when we plug that in, and again, hopefully you can, well, let's just do that. 0 squared plus or minus the fourth root of 28 squared. Remember, that's 28 to the 1/4 power. And then when you square that, you're going to get 1/2 power, so that's going to be a square root. It's going to be positive because you're squaring it, so it's going to be just the square root of 28 positive. Okay. Now, looking at that, if you did the same thing, if you plugged it in for x and then this was 0, you'd get the same answer. So this works the same way. If you plugged in 0 for the y and went with plus or minus the square root of 28, the fourth root of 28. Okay, so there's one answer. And then the other potential we have is using these ones over here. So again, I'm gonna, since we're squaring, we can kind of ignore pluses and minuses because they're going to get squared out anyway. I'll just put them here just to emphasize it doesn't matter which one we do. Plus or minus. So we get fourth root for the x, and we get plus or minus the fourth root of 14 for the y. Square them, they're both going to be positive. They both become the square root of 14, so you get the square root of 14 plus the square root of 14, which is 2 square root of 14. And so now which one's the minimum, which one's the maximum? Good question. So let's take the square root of 28. Now that's 5.29. Let's compare that to 2 times the square root of 14. Okay, so that's bigger, 7.48. So those were the options. This is gonna, so we'd have a minimum, our minimum value, square root of 28, a maximum value of 2, square root of 14. And again, it would occur, the minimums and maximums occur multiple times because there's actually 4 times that the minimum occurs and 4 times that the maximum occurs at each of the different critical points, right? 2 points here, 2 there. All right, that's the Lagrange multiplier question.